Magandang araw, grade 10 learners. Welcome to Math is Fun with Teacher Joy. And today we will be discussing how to solve problems involving permutations and combinations. But before we start, this is our learning competency for this week. We have to solve problems involving permutations and combinations. And at the end of this lesson, you are expected to solve problems involving permutations and solve problems involving combinations. So, let's begin. Solving problems involving permutations and combinations, we will be using Compendium of Notes pages 17 to 21. Now, a quick reminder, permutation is an arrangement where order matters, while combinations is also an arrangement but order does not matter. And with that, let's start answering problem number 1. A local school board with 8 people needs to form a committee with 3 people. How many ways can this committee be formed? Now, we know that there are 8 people to be taken 3 at a time. So, therefore, N is 8, R is 3. Now, we want to know how many ways this committee can be formed. With that, let's analyze the problem to get the right working equation to be used in solving the problem. Now, according to the problem, we need to create a committee with 3 people. That means order is not important. So, since the order is not important, we will use the combination formula, which is the combination of n things taken r at a time is equal to n factorial over r factorial quantity n minus r quantity factorial. And all we need to do is to substitute the values of n and r. So we have now the combination of 8 things taken 3 at a time is equal to 8 factorial over 3 factorial, quantity 8 minus 3 quantity factorial. Now we have to expand this factorial. Let's first begin with 8 factorial. 8 factorial will become 8 times 7 times 6 times 5 times 4 until it reaches 1. But instead of reaching 1, we have 8 minus 3, that is 5. So we have 5 factorial. Let's just expand 8 factorial until 5 factorial. And 3 factorial is 3 times 2. And then we have to simplify. 5 factorial and 5 factorial cancel out. That is just equal to 1. And if we will observe 3 times 2, that is 6. And we have 6 on the numerator. So cancel out 6, 3, and 2. And we have 8 times 7. So 8 times 7, that is 56. Therefore, there are 56 ways to form a committee with 3 out of 8 people. So that's how we answer problem number 1. Problem number 2. A local school board with 8 people needs to form a committee with 3 different responsibilities. How many ways can this committee be formed? Now, there are 8 people to be taken 3 at a time. Therefore, N is 8 and R is 3. Now, we want to know how many ways this committee be formed with 3 different responsibilities. So, we want to know what equation or working equation are we going to use in solving the problem. Now, take note, we are looking for a committee with 3 different responsibilities. These responsibilities can be a president, a vice president, a secretary, or so on. If there are certain different responsibilities, that means order is important. So if order is important, therefore, we will be using the formula in finding the permutation of n things taken r at a time, which is equal to n factorial over quantity n minus r quantity factorial. All we need to do is to substitute the values of n and r. So we will now have the permutation of 8 things taken 3 at a time is equal to 8 factorial over quantity 8 minus 3 quantity factorial. And we have to expand this. Before expanding, let's first simplify 8 minus 3, which is equal to 5 times factorial. So we have 8 factorial over 5 factorial. Now, we have to expand 8 factorial in such a way that we can cancel out 5 factorial in the denominator. So, we have now 8 times 7 times 6 times 5 factorial divided by 5 factorial. Now, simplify this by canceling 5 factorial and 5 factorial. That is just equal to 1. Now, we have 8 times 7 times 6. That is equal to 336. Therefore, there are 336 ways to form a committee with 3 different responsibilities out of 8 people. So that's how we solve problem number 2. Problem number 3. In a group of 10 people, a 1,000 pesos, 500 pesos, 200 pesos, and 100 pesos prize will be given. How many ways can these prizes be distributed? We know that there are 4 prizes to be given, and there are 10 people to be chosen to receive the prize. So therefore, N is 10 and R is 4. Now for the working equation, since we are dealing with prizes, we will be using permutation. Since in prizes, order is important. Okay, now we will be using the permutation of n things taken r at a time, which is equal to n factorial over n minus r quantity factorial. Now substitute the values of n and r. We will now have the permutation of 10 things taken 4 at a time is equal to 10 factorial over 10 minus 4 quantity factorial. Now 10 minus 4, that is 6, so we have 6 factorial in the denominator. Now we have to expand 10 factorial in such a way that we can cancel out 6 factorial in the denominator. So expanding 10 factorial until 6 factorial, we have 10 times 9 times 8 times 7 times 6 factorial. Now we have to simplify this by canceling out 6 factorial in the denominator and in the numerator. So 6 factorial divided by 6 factorial, that is 1. So we will now have 10 times 9 times 8 times 7, which is equal to 5,040. Therefore, the prizes can be distributed in 5,040 ways. So that's how you solve problem number 3. Problem number 4. In a group of 11 people, 500 pesos prize will be given. How many ways can the prizes be distributed? Now, according to the problem, there are 11 people and 5 will be chosen to have 500 pesos as their prize. So therefore, N is 11 and R is 5. Now, we want to know how many ways can these prizes be distributed. Specifically, we are distributing 500 peso prize. So therefore, order is not important. And with this, we will be using the equation, the combination of n things taken r at a time is equal to n factorial over r factorial, quantity n minus r quantity factorial. Now we have to substitute the values of n and r. So we have now the combination of 11 things taken 5 at a time is equal to 11 factorial divided by 5 factorial, quantity 11 minus 5 quantity factorial. Let's first start by subtracting a 5 from 11. So 11 minus 5, that is 6. We now have 6 factorial in the denominator. Now let's expand this equation. 11 factorial will be expanded until 6 factorial, and 5 factorial will be expanded until times 1. So we now have 11 times 10 times 9 times 8 times 7 times 6 factorial in the numerator, and in the denominator we have 5 times 4 times 3 times 2 times 1 times 6 factorial. Now we have to simplify this. So 6 factorial divided by 6 factorial, that is 1. And in the denominator, we have 5 times 2, that is equal to 10. So cancel out 10. And 9 divided by 3, that is equal to 3. And 8 divided by 4, that is equal to 2. So we now have 11 times 3 times 2 times 7, which is equal to 462. Therefore, the prizes can be distributed in 462 ways. So that's how you answer problem number 4. Problem number 5, Makabayan National High School held an in-campus feature writing competition about frontliners. There are 14 participants from different grade levels competing for the first, second, and third place. How many ways can 3 people be chosen? Now, according to the problem, there are 14 participants, so n is equal to 14, which will compete for the first, second, and third place. So therefore, R is 3. Now, for the working equation, let's first identify if the problem suggests permutation or combination. Now, take note of these words, competing for the first, second, and third place, in which it suggests that order is important. So, since order is important, we will be using as the permutation of n things taken r at a time is equal to n factorial over n minus r quantity factorial. Now, we have to substitute the given values of n and r. We now have The permutation of 14 things taken 3 at a time is equal to 14 factorial over 14 minus 3 quantity factorial. Now let's start subtracting 3 from 14. So 14 minus 3, that is 11. Now we have 11 factorial in the denominator. Now let's expand 14 factorial in such a way that it will end until 11 factorial. So let's expand. We now have 14 times 13 times 12 times 11 factorial. Now cancel out 11 factorial on both numerator and denominator. We now have 40 times 13 times 12, which is equal to 2,184. Therefore, there are 2,184 ways to choose 3 people from 14 participants. So that's how you solve problem number 5. Problem number 6. There are 7 questions on quarantine assessing test. She only needs to answer 5 of them and choose any 5 that she wants. How many different combinations of 5 test questions can Quarantina answer? So, based on the problem, Quarantina have 7 questions and she only needs to choose any 5 that she wants. So, therefore, N is 7 and R is 5. Now, take note of these words. So, we are dealing with the number of combinations of 5 test questions that Quarantina can answer, in which this suggests that order is not important. Therefore, for our working equation, we will be using the combination of n things taken r at a time is equal to n factorial over r factorial, quantity n minus r, quantity factorial, and then substitute the values of n and r. And we have the combination of 7 things taken 5 at a time is equal to 7 factorial divided by 5 factorial times quantity 7 minus 5 quantity factorial, and 7 minus 5, that is 2. So we have 2 factorial in the denominator. So now we have to expand 7 factorial in such a way that 5 factorial will be cancelled out in the denominator. So expanding 7 factorial until 5 factorial, we have 7 times 6 times 5 factorial. And 2 factorial is 2 times 1. Then after that, simplify by cancelling 5 factorial. And 6 divided by 2, that is 3. So we now have 7 times 3. 7 times 3, which is equal to 21. Therefore, the questions can be chosen in 21 ways. So that's how you answer problem number 6. Problem number 7. If 3 marbles are picked randomly from a jar containing 6 red marbles and 8 green marbles, in how many ways can it happen that at least 2 of the marbles picked are green? So based on the problem, we have 8 green marbles and 6 red marbles. And with this, we must pick 3 marbles randomly, in which at least 2 of the marbles picked are green. This implies that there are either 2 green marbles and 1 red marble picked, or there are 3 green marbles and no red marble picked. And this is the arrangement of closed restriction. Again, we will be picking them randomly, so therefore, this problem suggests combinations. Now, since we're dealing with combinations, on the first arrangement, 2 greens and 1 red. So the combination of 8 green taken 2 at a time multiplied by the combination of 6 red taken 1 at a time. While on the second arrangement, we will pick 3 greens. So we have the combination of 8 things taken 3 at a time, and we will not going to pick any color red marble. Now, based on this arrangement, we will now have our working equation, the number of n ways of picking 3 marbles randomly, in which at least 2 of the marbles picked must be green, is equal to the combination of 8 green marbles taken 2 at a time, multiplied by the combination of 6 red marbles taken 1 at a time, plus the combination of 8 green marbles taken 3 at a time, times the combination of 6 marbles taken none at a time. Now let's evaluate each combinations. Let's start with the combination of 8 green marbles taken 2 at a time, that is 28. The combinations of 6 red marbles taken 1 at a time, that is 6. And the combination of 8 green marbles taken 3 at a time is 56. And the combination of 6 red marbles taken none at a time is 1. Now 28 times 6, that is 168. And 56 times 1, that is 56. And 168 plus 56 is 224. Therefore, there are 224 possible ways that at least 2 of the marbles picked were green. Problem number 8. You are transferring to a new house. You have a collection of books, but you cannot take them all with you. In how many ways can you select 7 books out of 10 and then arrange these books on a shelf if there is space enough for only 5 books? Now, analyzing the problem, we have 2 things to solve. The first one is you have to select 7 books out of 10, and then out of this, you have to arrange the books in a shelf in which there is only enough space for only 5 books. So let's first start answering this statement. You have to select 7 books out of 10, in which N is 10 and R is 7. Since you have to select 7 books out of 10, this statement suggests combination, wherein order is not important. So you have to evaluate the combination of 10 books taken 7 at a time, which is equal to 120. Now for the second problem, you have to arrange these books in a shelf, but there is only enough space for only 5 books. Now this statement right here suggests that order is important. Therefore, you will be using permutation, in which N will now become 7 and R will become 5. And you will be using the permutation of 7 books taken 5 at a time, which is equal to 2,520. Now, the number of N ways for you to get these 2 conditions is equal to the combination of 10 books taken 7 at a time times the permutation of 7 books taken 5 at a time, in which the combination of 10 books taken 7 at a time is 120, and the permutation of 7 books taken 5 at a time is 2,520. Therefore, we have 302,400 ways. So there are 302,400 ways that you can select 7 books out of 10 and arrange another chosen 5 books on a shelf. So that's